All right, now I'm sure that after the last video, you're thinking, exponential equations was so messy and so long. We haven't even gotten to logarithmic equations yet. Logarithmic equations are way better. You might not think it might be backwards, but logarithmic equations are going to be much easier to solve. And we're going to solve these first ones, again, two methods, definition first, and then the one-to-one property afterwards. So the definition is just like 6.6.2. The next video is just going to be like 6.6.1. All right, isolate the log. And then use the inverse, put it in an exponential form. I don't think this video is going to be too hard as long as you remember these steps. Video 2, that's a really challenging one of this section. All right, that's in the past. Let's do example 4. Solve the following. 5 times the log base 7 of n equals 10. So the log isn't isolated here, right? We want this red thing to be completely by itself. But it's getting multiplied by 5. So we undo that by dividing both sides by 5. 10 divided by 5, that's just 2. That's step 1. And now put it in exponential form. Base of the logarithm, base of the exponential. Input becomes the output. Output becomes the input. Oh, we're done. N is 7 squared. That's 49. It doesn't get much worse than this. Let's check our answer. All right. If I can find my Desmos. All right, we said that 5 times the log base 7 of n, which is 49, that equals 10. Great. Cool. Boring. Come on. Give me some problems like this again. Do part B. 4 plus log base 2 of 9x equals 2. We want this logarithm isolated. We want this red part isolated. So just subtract 4 from both sides. It's going to give us log base 2 of 9x equals negative 2. Convert it to exponential form. Base of the logarithm, base of the exponential. Input of the logarithm becomes the output. Output of the logarithm becomes the input of the exponential. That's what inverse functions are all about. Inverse functions are all about switching the inputs and the outputs. Now it's a little bit more work. Negative exponent just means reciprocal. So 9x is just 1/4. Divide both sides by 9. X is 1 over 36. Not too bad. Check our answer, 1 over 36. Plug this into the equation. See if the equation's true. 4 plus log base 2 of 9 times x, which was 1 over 36, that equals 2. Just like the equation said it would. Ugh. One more example, and that's the whole video. Example 5. Solve and graph both sides to check. All right. Log base 9 of x minus 5 equals negative 4. Negatives cause a problem for exponentials, but remember the range of a logarithm is all real numbers, so it's okay that there's a negative here. As long as there's not a negative in here. All right? Get that logarithm isolated, convert it to an exponential equation. Right? This is where it was isolated, and then we converted it to an exponential equation. So to isolate, let's just add 5 to both sides. Convert it to an exponential equation. 9 to the first power equals x. X is equal to 9. It's as easy as that. Let's graph both sides of the equation like the problem asked us to. On the left side of this equation, we have y equals log base 9 of x minus 5. And on the other side, we have y equals negative 4. Where do these intersect? When x is equal to 9. Was that our answer? X equals 9? Oh, it was. I got worried there. Yeah, they intersect when x equals 9. That's when the logarithm equals that horizontal line. That's the whole thing. All right. Good luck and enjoy take a rest, you know, after that last video.